Hey guys, welcome. Well, today's topic is interesting. What is a load balancer? Now, I'm going to make some drawings, some sketches later, but I want us to go to the official documentation by Azure themselves on what a load balancer is, and we take it from there. Please hold on. Let's do this right now. So, load balancer. This is Azure speaking. So, Azure load balancer. Okay. So load balancing refers to evenly, a keyword, distributing load for incoming traffic. Now, incoming traffic is always coming on the ingress side, okay, across a group of backend resources. Another important keyword, backend resources. And typically they are servers, all right? So Azure Load Balancer operates at layer 4. Now, in the OSI model, this is OSI model. Please do not take such a pizza away. So application session, physical, please, data, network, transport, session, presentation, away. All right, so this app, present, session, transport, network, data, physical. Okay, it says layer 4. So one, two, three, four. Transport. So then there will be things like your TCP and your UDP. Okay, all right then. Okay, so it operates at layer 4 of the OSI model, which I'll get to further. It's a single point of contact for clients. Why? Because your clients, like your machine and mine, sits on the World Wide Web. Try to speak to an Azure pool of service, seven, maybe a website. So website of 443. Now your load balancer, maybe I should just use green for that. Your load balancer will evenly distribute the traffic to these. Okay, so traffic will come on port 80 or 443 or whatever you set it to do, and it would evenly distribute that across, okay, to the servers. So this server one, server two, server three. So one, two, three. These are replicas. All right, replicas. Okay. All right. So let's carry on. So the key word again is load balancer. Now, front end to back end pool instances. So front end, mostly front end is public facing. Okay. So you have a pool in there. And in back end, those are areas where you don't have direct interactions with. So if I had my computer here and I was talking to your load balancer, speaking to this service also needs to speak to backends like databases and other bits, which I cannot get to. Okay, but my transaction is just between this load balancer and server that I'm saved my session from. Okay, and that's it. All right, so that is simply there. So these flows are according to configured load balancing. So pay attention to these important things. Rules. So element one and health probes. Element two. The backend pool instances can be Azure virtual machines or instances in a virtual machine skill set. So you could have a virtual machine skill set. So that's a VM. Yeah. Set is a replica of each other. And then of course you have a single server instances which you can configure to replicas, okay? And with the load balancer sitting in front of it. Okay. Or this other one as well. All right. Now, a public load balancer can provide outbound connections for virtual machines inside your virtual network. These connections are accomplished by translating their private IP addresses, of course, to the public IP addresses. Public load balancers are used to load balance internet traffic to your VMs. So you got VMs, and they need to go to the internet, which is just, oh, I got one here. So you put a load balancer there, traffic hits it, and it's translated across to the internet. So this guy can now, for example, ping 8.8.8.8, 8.8.8.8, 8.8.8.8. So they're on the internet, they can talk to the internet. So they can go through this guy and go across. All right. Okay. So an internal or private load balancer is used where private IP addresses are needed at the front end only. Internal load balancers are used to load balance traffic inside the virtual network. The load balancer front end can be accessed from an on-premises network in a hybrid scenario. So when I scroll down further, by the way, this link I'll put it in the video, or I should say it's in the video right now. Okay, let's have a quick clear up there. So Microsoft is telling you that TCP port 80, okay, that is uh, the OSI layer 4, okay, port 80, web traffic. All right, so traffic is coming from your laptop or mine, and its ingress here. It hits the public load balancer. Now it's public, so it can face the internet, right? So it will have an IP address here. And normally they call this a front-end IP address. And then behind the scenes, this guy will balance the load between these VMs. So let's say this is VM1, 2, and 3. But this is a replica of the other. They're all one and the same. Okay? So as far as this guy is concerned, he has no idea which of the servers is serving him. He just hits one and that's it. He's happy. But these systems also perhaps need to write to some systems here. Okay. Now they could write to either this one or that one or that one. Okay. So then to do that, they also need to be load balanced internally. And this time it's in 443. That's HTTPS. Okay. And that does it bit as well. Let's scroll down a bit further. Let me just scroll down a bit further and let's we can get. So virtual network, of course, VNets. You can see that in the previous video. Balancing multi-tier application by using both public and internal load balancer. So for more information on individual load balancer components, see Azure Load Balancer components. Okay, let's read this note, and then I would go into why we use a load balancer, and then from there, we'll go to the drawing table, drawing board, and then let's do a live demo. Okay. So balancing multi-tier applications by using both public and internal load balancer, just like demonstrated earlier. For more information on the individual load balancer components, see the Azure Load Balancer component. So when you go to this information, which will be in the video description, yeah, it will take you there. Azure provides a suite of fully managed load balancing solutions for scenarios. So if you're looking to do a DNS-based global routing and do not have requirement for transport layer security, TLS protocol termination, SSL offload, or per HTTP or HTTPS request, or application layer processing, review the traffic manager. So traffic manager does this DNS-based global routing. Okay. If you want to load balance between your servers in the region at the application layer, review the application gateway. Another very beautiful system there. Okay, if you need to optimize global routing for your web traffic and optimize top tier and user performance and reliability through quick global failover, see Azure Front Door. Okay, your end-to-end scenarios may benefit from combining these solutions as needed. For an Azure load balancing options comparison, see overview of load balancing options in Azure. So now let's focus on why we use load balancer, and then we can get into sort of pretending to create one, which I'm not going to execute all the way. So with Azure Load Balancer, you can scale your applications. So the load balancer gives you the chance to scale the applications and create highly available services. This is the keyword. Keyword. Load balancer supports both inbound and outbound scenarios. So it's not just traffic coming in to the backend pool. You can also have the traffic leaving from any of these pools, just like we saw earlier. Okay. Okay. Load balancer provides a low latency and high throughput and scales up to millions of flows for all TCP and UDP applications. So it's pretty powerful. Okay. The key scenarios that you can accomplish using Azure Standard Load Balancing include load balance internal and external traffic to Azure virtual machines, increase availability by distributing resources within and across your zones, configure outbound connectivity for Azure VMs we saw that earlier, use health probes to monitor load balance resources. Very important because you need to know that this VM is still listening on 80 or let's say listening on 443. So when you create your load balancer, you create a health probe and it's normally symbolized as something like that. Okay. And yeah, so it will just be checking. It's like connected to the server here, and the server says, I'm still listening to 80, I'm still listening to 80, I'm still listening to 80. It's almost like pinging. It's not really, but it's just checking. And so when traffic comes, the load balancer says, okay, health probe, I know you are still listening on 80, so I'll give this traffic you to 7. Okay, so health probes are like that. Okay, and employ port forwarding to access virtual machines and virtual network by a public IP address and port. It enables the support for load balancing of IPv6. Okay. Standard Load Balancer provides multi-dimensional metrics through Azure Monitor. These metrics can be filtered, grouped, and broken out for a given dimension. They provide current and historic insight into performance and health of your service. All right, you can go ahead and read this by yourself. I'm not going to sit here and read for you. All right, so take your time and read for yourself, my friend. Take your time to read. All right. So the important things about NSGs, and you see them when you read it. So go ahead and do that. What I'm interested in is why don't you create one ourselves? Um, so in here, um, we're going to create a load balancer. So you can see that I've already started on one, and I said the resource group is called North Europe Load Balancer. That means that the geographical location that I want this load balancer to be is in North Europe. So let's say NE for sure. Okay. Now the name of my service is called Apache Web Service Load Balancer. All right. Now, I could also put NE in front of it to represent that this load balancer is in North Europe. Okay, it's much more meaningful. And then the region, of course, must reflect what I've said there. So it's North Europe. What am I going for? Am I going for a basic one or standard? I've chosen standard load balancer. Okay. And when I scroll down, well, there's no scrolling down. When I move right, I will need to create something called frontend IP. Now, frontend, what does that mean? So I've got my load balancer. Okay. Now, this is the World Wide Web. The load balancer should be able to speak to the internet. Okay. So it sits here with something called the public facing IP address. But in the load balancer world, we call it FEIP. And so let's say IP address is 20x.yze.jc blah blah blah. And then it's load balancing across to this backend pool, which might be here. Let's say your backend pool. Okay, here we go. Okay, so that's the front end IP. So it's going to be definitely what? Public IP address. So let's go ahead and create one. Sure. Click and add front end IP. Okay, you type a name in there, you know, and then whatever you want to call it, you call it. Okay. All right, so that's how you create that over there. But the rest of the assignment is something that you do yourself, but let me just give you a backend um, back, back, backdrop information to it. So the backend pool, these are the servers that you're going to load balance against. So let's say we had four. So server X, Y, Z, E. So they will be in one bucket called the backend pool. And your load balancer will sit in front of it and will take traffic and will give it to Y, X, Z, E. Okay, so this is going to be called your, can I find something fancy? This is going to be called your backend pool. Okay, so backend pool is going to be that. Okay, then you create your inbound rules. Now, inbound rules, it's almost like an access list. Very interesting. So you have an inbound rule here. This is the inbound rule. Okay. That means that when traffic comes to your load balancer on public IP address 20x, the ycd.xab, and this is just a pretentious IP address. It's not IPv6, it's just an IP address. So you can make up anything. So the front-end IP address, which is an IPv4, when traffic is hitting here, of course, as you know, it's layer 4. So it's going to check the TCP or the UDP and you see the port number. So there's load balancing inbound rules will say, okay, if you're port 80, okay, you're going to port 80 again, and then means that this server or these servers are listening on port 80, all of them. And then you can go to any of these, okay? And load balancing rule could have 443, and again, the servers was listening to on 443, 443, 443, 443. Let's say this listening on 552, all right? So 443, 552, 552, 552, 552, and 552. So traffic coming this way can go any of these directions. So your help probe, which sits here, will check to make sure that these ports 80, 443, 552 are being listened on. And will check the health of your server in regard to listening on those ports. And if for some reason it doesn't listen on these ports, it will mark the server as unhealthy and will not allow the load balancer to serve resources from the server to the world. Because you want to make sure that there is integrity with what you're serving. Okay, so the help probes are very important. Now the help probes will also have rules that would also have the exact same copy as your inbound rules. Okay, 443, 552, and what have you. Then, depending on what you're doing, you could also have advanced rules. Maybe you want these guys to also go out and also want to specify what they can get to, and then the port numbers that they need to use to get out. Then tags if necessary, and then you create that. So this is a task for you. What I'm going to do is there is Microsoft uses something called like self-learning or self-paced labs. I'll stick the link, or I have stick the link in the description below, um, which you can follow to create a load balancer. And it's very important for you to practice. Okay, always understand the concept. I'm going to go over the concept one more time. Your load balancer would have a name, would have its front-end IP, you already have service, which you will group into backend pool. You have inbound rules, which is almost like an access list or a filter to direct your traffic to where it needs to go to. Outbound rules, when necessary, you might need this to also go outside. You could also create that there. The tags, and of course, you review and create. So that's what it's all about. In a couple of videos to come, I will show you how to create this load balancer with infrastructure as code, and we will use our favorite Terraform. I'll also show you Azure's native, what do you call this one here? Um, Bash, and then PowerShell. So until the next one, thank you for viewing. Of course, feel free to subscribe, like, share, comment, and ask questions and suggestions. So do suggest anything. All right. Okay. Thank you. So we're going to take some of these Azure topics and we go through them one by one. If there's a video you want me to make on a certain subject, let me know and I'll prep up and we can sort of talk about it like this. Okay. All right. Thank you for your time and all the very best. God bless. Bye.